All right. Coming up next, this is the keynote. This is the highlight of the day. Don't miss it. I had notes, and then the notes disappeared. Okay. I'd like to bring up to the stage Amanda Hogan. Yay, exciting. Okay. Can start switching your laptop over while I start talking. Okay. Amanda never ceases to amaze me with her innovative approaches to getting kids excited about coding and about technology. She is a teacher at a girls' school in Sydney, and with them, she gets them to build phone apps and sew wearable technology into clothes with little flashing LEDs and everything. She spends her spare time helping out with the Girls Programming Network, getting even more girls excited about computer science, and also the current president of the ICT Educators New South Wales. I don't know how you do all of it. Please welcome Amanda.
Okay, I have to do all of that again. I'm also a computer education specialist for the Australian Computing Academy. So I'm a part-time teacher this year and a part-time computer education specialist. When we've defined that properly, I'll let you know what it is. But at the moment, it's just getting a new national project up off the ground. So we have some federal funding, and we're trying to reach 300,000 students, which turns out to be quite a lot. And so where the 300,000 comes from is, we did an ABS search, and Year 7 and Year 5 students across Australia have been funded by the federal government for free to do something. And it was our job to go and work out what that something was, and so I'm telling you a bit of the story of that today. Okay, so in 2015, the government decided that maybe the world of work and industry was changing a little bit. And that was quite late for them to come to the party. Handily, ACARA had decided that several years previously. And so we had a national curriculum coming in digital technologies. And so the federal government said, okay, as part of the National Innovation and Science Agenda, we are going to fund something digital technologies. It's going to be easy. Okay, so we have this national curriculum that was drafted in 2012 and then went through. Curriculum is, as everybody here would know, excruciatingly slow. So drafted in 2012, which took some time to get to that point, then goes into consultation phase, and people give feedback on what's good about it, what's bad about it, what's not going to work logistically, and then it gets formed eventually, and then once it's formed, people get really excited and start implementing it straight away, unless you're New South Wales. And so now we have implementation of the national curriculum-ish, mostly. 2019, the rest of that puzzle will fall into place. Okay, so now we have 300,000 students, plus more coming on all the time because of Year 6 and Year 8, and then Year 9 and Year 10, which the federal government haven't quite worked out how to do yet. So we're just focusing on the 300,000 because that's enough. And we're really struggling to find trained teachers who are capable of teaching this in schools, and also to train teachers as they come out and change, or people that are changing from subject to subject. So we have what we would call a wicked problem. It's kind of nebulous. We have some teachers, we're not sure how many of them are awesome rock stars at coding. We don't know how many of them are really terrified of computers, and there's a huge spectrum in there. And we have to reach the ones that need the help and leverage the ones that don't need the help, and somehow reach this extraordinary number of students. So how do we solve this problem of getting digital technologies curriculum when we don't have the people to deliver it. The other problem that compounds this is, and I am a New South Wales teacher, embarrassed about that little black hole in Australia, but this is the New South Wales primary school, upper primary breakdown of hours in a day or in a year. And so science and technology gets 6 to 10% of the curriculum. Now, let's be honest, maths and science are where NAPLAN is. So, maths and English are where NAPLAN is. So they kind of creep a little bit bigger around the edges. So let's call science and technology 6%. Technology is half of that-ish. So 3% being generous. Digital technologies is half of that. So that's 1.5%. So we're talking 25 minutes a week. Yeah. So that's not, turns out it's not a lot of time to do really cool world-changing projects. And so we have to work out how to make it easy, make it doable, and also to join it with other areas of study so that we can kind of hit two birds with that one stone, adding to our problems. Okay, so ACARA, which is the Australian Curriculum Assessment and Reporting Authority, if you're not familiar, did come up with 10 key concepts for our digital technologies curriculum. And I think they're really useful. I think they're really useful because I have a computer science degree. So I know what abstraction is, but they're not all that useful to the average teacher who has to, and I don't mean average as in bad, I mean average as in, mean the people that have the training in education. So I'm going to tell you a story about my friend Karen. Karen is fantastic. She is an awesome teacher. She is a teacher librarian, and she is always pushing her practice forward. She tries to integrate technology wherever she can. She's using web tools. She was one of the first Web 2.0 people. Everything has a wiki or a blog. She's really keen and really excited about education and leveraging technology to make education better. So then she went on maternity leave and got an email while on maternity leave that actually now she was in charge of digital technologies curriculum for years 5 and 6. Okay, so why? Because she knew how to turn on a computer, and they're like, computers, it's the same. And that's a bit of a worry because digital technologies and using computers isn't the same. But she's a good teacher. She's really keen, enthusiastic, and knows how to read a curriculum. So off she went and she read the curriculum, which is, I think by design, a little bit fuzzy around the edges. It's not a New South Wales dot point curriculum that tells you exactly what to do and what to cover, because they want it to be a little bit flexible to fit in all kinds of places. But the problem with that is that people that don't have the training, like Karen, read all of this stuff and then have to sit on Webipedia working out what all those words mean, and then still aren't sure how to do that with a classroom of 11-year-old boys who all smell a little bit. So she was actually doing things that were not what should be covered in years 5 because of how the elaborations are structured. And that's unfortunate. So we need to help her because she is one of our super teachers. So what we did at the ACA, we started off this year, got the ball rolling with analysing the digital technologies curriculum in detail. Don't read this slide. But I'm just showing you that we've broken those 10 kind of weird computer sciencey type terms down into a myriad of terms that have very specific definitions and show a trajectory from K through to 10. We'll worry about senior later. So that shows how things like sequencing changes between year 2 and 3 and year 9 and 10, so that we can show the students how to grow from one place to the other, and we can have planned programs that facilitate that. So we not only did that, but we started to categorise the internet. And all of those fantastic programs that are already in existence, things like Code Academy and code.org, and tick those concepts off so that we can work out where the digital technologies is already being met by other resources. Okay. So I'm at PyCon. I better tell you why we're doing Python in Year 7. And it's because Year 7 specifically says it must have a general purpose programming language. General purpose is meant to be as opposed to block-based. So all of the people that have been using Scratch for Year 7 game projects have to kind of think about how in the future to switch that over to something accessible but also general purpose. So let's be typing rather than dragging and dropping. That's not going to happen straight away, but it is meant to happen as Year 5 take on those block-based programming languages, and then Year 6, by the time they get to Year 7, they're ready for the next step. So why Python? Mostly because of that. So we have C and JavaScript and Python, and the dive-in point for any text-based programming language is Hello World, and Hello World in Python is one line, and it's pretty easy to start. So pretty easy to start is a really big thing when you're teaching a whole class of 11-year-olds, particularly when the teacher's still a little bit nervous about what they're doing. The downside of Python is that there's a whole section of the digital technologies curriculum that requires the design of a GUI, and we can't do that very well in Python. If you want to have a debate about that, we can do it at morning tea. But we can do it with some tools, but it becomes really complex. But the benefits also stem from the fact that there's no GUI, because there's no distraction of how do I make it appear. We can actually play with just solving the problems and learning some of those syntax, some of the syntax words. So here is the website for the Australian Computing Academy. We launched it 27th of July. We had the Education Minister come out. We had a bunch of Year 5 students in a school. Everybody was coding. There were reporters there. We managed to sneak into the end of one of SBS's stories for that night. So you may not have noticed that it hit all of the national news. Didn't quite make waves. Apparently Boris Johnson was in town and we didn't rate. But we do exist, and you can go to this website right now. And what we've got is a really good start. We have 4 challenges already available. Some of them meet the needs of 7 and 8. Some of them meet the needs of 5 and 6. One of them meets the needs of 5 and 6. One of them is kind of a transitional one, so we're not doing Python in the 4th one, so it would suit Year 5 or Year 6, but it does touch the Year 7 geometry curriculum in maths. So we're actually trying to cross that boundary between digital technologies and other subjects. Okay, you can also go here to have a look at how we're unpacking the curriculum. So find out what some of those wacky words mean. And we also have workshops. My team, and less me because I'm part-time and still have classes to teach. But we're travelling the countryside running workshops for teachers. And they are 2-day generally. At the moment they're free. We're dealing with the computer education groups in each of the states. So DLTV here, ICT educators in New South Wales, QSite, ICTI, Intiact, and so all of them. And we're sponsoring the catering and the whole workshop. That might be changing in the future, where we actually charge teachers for catering so that we get a lower dropout rate. So if you really want freeness, get on that quickly. So we have 2 days. The first day is unpacking the curriculum. So what do these terms mean and how do we do them even without a computer, we do some computer-free games. We have a look at Lego. It's very fun. It's very interactive. The teachers are kind of like the students, seeing how this would work in a classroom. The second day is more working with our challenges, so learning either the Python language or Blockly, which has Python mirrored underneath so that you can have a trajectory from clicking together blocks to I can type this stuff and actually it's a lot faster. Okay, so that's workshops. But I have a concern. And this is part of that wicked problem we're trying to solve. I'm going to tell you about an 11-year-old I know. So this is a kid that is unusual. She has been coding in Python since she was 8 years old, and she understands dictionaries, she understands lists. She's like, that's year 7 to 9 curriculum, so she's ahead of the game. But she was doing a computing competition and got faced with a tricky file processing problem. So you had to read in a file, you had to do something to each line to analyse the text, pull out some information, and she couldn't get it to work and fell apart. Tears, I'm hopeless at this, programming is too hard, I don't want to do this anymore. And my heart hurt just a little bit, because here's a kid that really is above the standard, but still lacking that resilience to say, okay, problems are hard, and I probably need to think of another way of attacking this, and just went straight to disaster. So we have to look at that as a possibility, not just for our extraordinary kids, and there will be a bunch of them in 300,000. There'll be a bunch that know an awful lot more than the teacher. There'll be a bunch that are ahead of the curriculum, but there'll also be a really large bunch at the other end, and we have to learn how to build that resilience. And in my experimentation, and it's not very scientific, but I've found that in my classrooms, that kind of resilience can come from context. It can come from not just learning this stuff because the teacher said, not just learning this stuff because I'm trying to get a certificate, but learning it because I'm trying to solve a literal problem. I'm trying to process a file because it's got my high scores in it, and if I don't process that file, then I can't update the high scores and my game is not as good. That's a context, it's a problem that kids actually want to solve. So we have to come up with ways to make our problems the kind of problems that students want to solve. Okay. Discouragement is real, part 1. This is, I have access to a lot of data now, working with the ACA. It's run on the Grok Learning platform. They've been doing this for a long time with students. They have thousands of results to trawl through. And what they find with Hello World is that there's an almost 50% fail rate on per submission. That's an extraordinarily high number. Now, they tend to be small problems, like I didn't capitalise the H and the W, I didn't put a comma in, I didn't put an exclamation mark in, I mistyped world. But the second graph is actually passed after how many attempts. So 63.5% passed after 0 attempts, and then it trails off, and you can see that after 6 attempts, quite a number of the students are still going. But you might notice that there's a little arrow there that says page 2. Our winning score on this is 28 attempts. And that, if we don't have a safety net in the classroom to say, okay, let me give you a hand with that, then that's where we have kids that just go, I'm out. You know, programming is for other kinds of kids. And this is the second step. And this is a huge step in programming teaching. from I'm just making output to I'm making dynamic output based on a variable. This variable thing turns out to be a hard thing to grasp. It's quite abstract, it's not really representable in life except with buckets. And so the idea that we take input from the user, we store it somewhere, and then we kick it back out to the screen, joining things together, that's quite hard. Actually, quite hard is really an understatement here. 75% fail, and we have about 50% pass on the first or second attempt. But this has 4 pages. Our current winning score, there's quite a number in the hundreds, and 128 is the highest score for, and we never want to beat that score. So for how many attempts to solve this. And this is with a really good marking system that gives advice to users as to the programmer as to what they might have done wrong. Like it says, check your capitalization. How about you check your white space? That kind of thing. And so kids don't read. That's a truth that we have to deal with. But even without reading, that's a lot of attempts. So we have to deal with resilience in the high levels. Don't treat yourself so harshly. We have to deal with resilience in the low levels. We have to have a safety net. We have to deal with resilience among teachers. We have to have a safety net for them. So I'm building up to tell you all of the things that make this quite a hard project. So we know that we have a digital technologies curriculum. We know that there are many students in Australia, lots and lots. And there are a lot of teachers who are unprepared to teach it. We have developed some things. They are cool things. They are worthy of trying. They are free for Years 5 and Year 7 students. You just have to apply. And we're travelling the country to prepare teachers for this curriculum and how to teach it in the classroom. But that's not all that scalable for people travelling the countryside. So we have more time. This project lasts till the end of 2019, and by then New South Wales, will be on board. We have lots of enthusiasm, we have lots of ideas, but we need scalable solutions. And we need to be able to meet the needs of all students and all teachers, which is an arduous task. So I get to do some show and tell. Just give me a second, come on Windows. Right, so this is the Digital Technologies Challenge for Year 7. Well, 7 and 8, but only the Year 7s get it for free. And it's built around the Digital Technologies curriculum. It's not, if you're familiar with the Digital Technologies curriculum, it's not hitting every point. It's not possible to hit every point in this kind of compact program. So the idea is that it's built around 4 weeks, an hour to 2 hours a week, depending on how much experience your students have. And it is project-based, which is where we came back to that problem of students needing context to have a bit more resilience. Turns out coming up with projects that are going to be able to be done and be interesting when you don't know how to do if statements yet is hard. But we've given it a red hot go. So this is our projects when you don't know if statements yet. And this is a game of Mad Libs. There's a lot of typing, which is a bit rough, but handily with Python you can copy and paste. So we have a bunch of inputs, and then we're teaching F-strings because casting is difficult and concatenation is difficult, and so F-strings take some of that out of it. And so the students get to make a fun letter home from camp, based on some random words that get entered by the user. And so they can get kind of fun and ridiculous. Now, this isn't quite right. If I look over here, this is my definition of my problem and what the output should look like. And over here, I have typed a bunch of stuff. I have all the variables and I have just about everything. And then I submit it, and you'll see that I failed. And it tells me what I passed and what I failed. So the words in the first line, the capitalization and punctuation, the spacing, all of those things are right. It's ticking us off one at a time. What did I get down to? I have, says I have a typo on the 7th line. I'm actually missing the 7th line. So this bit here, see you soon, Jane, I need to put in. I missed that, whoops. Okay, turns out I can't type. Okay, so let's run that. Somebody give me a name.
Izzy.
Okay, a relation.
Second cousin.
Okay, a noun.
Dog.
Plural animal. Did you say murder? It's not an animal, neither is it a plural. That, excellent teaching, Edwin. Crows, okay. Sport. This is a geek room, we don't know about sport. Adjective.
Spiky.
Spiky. Another adjective. Blue. Verb. Murder. Okay. So we've got, dear second cousin, camp dog has been spiky so far. Tomorrow we will play football if the weather is okay. Today it has been raining cats and crows all day. If we cannot play football, maybe we will just murder. I'm sure it will be blue either way. See you soon, Izzy Paul. So nonsense, it turns out to be a great engagement point for kids. They think that's fun. We think that's fun. Okay, so that's how you do a game that is kind of gamey, but doesn't have any if statements in it. And then I'll show you what the final project looks like. So when they get through, we do design backwards. So we want them to be able to do something interesting. Here are the things they need to learn about in order to do something interesting. So it's tailored to get to the final project. So how much of the text processing they learn is because of what's coming later. If statements are necessary, they have if statements that also have elifs and elses. They have loops. We had to cut out for loops. It hurt us a little bit. It's a physical reaction. But while loops are more useful for the project, and for loops and range, they take some teaching, so we skipped it and we'll do it on the next one. Okay, so this is Captain Featherbot, and as you can see, I'm amazing. I passed already. Okay, so this is a little chatbot that says R a lot. R. And that's how we make it fun, that he says some ridiculous things and likes his boat, Bodie, is it Bodie McBoatface? Yeah. Floaty McFloatface, something like that. Yeah, and says landlubber. Okay, so the idea is that we pull out some keywords from the text. So if it has boat in it, then the response will be this. If it has feel in it, then the response will be this. And we start off really simply with, let's just have a really basic conversation. Slightly less basic than the Facebook bots were having with each other, but a really basic conversation nonetheless. So we're making sure that they convert to lower so they can check that words are case insensitive, and the kill phrase is go away. So we start off with just a really straightforward while loop, and then once they say go away, it has a series of print statements, shiver my timbers, farewell, name your landlubber. And then we get a little bit more complex. So by the time they get to the last part, the fourth part of this, they're actually doing some kind of cool stuff. So we've got name we're storing as a variable. We then slice it in occasionally. We have, if they say I am something, then the captain will reply with last time I was doing that, then I went to sail the seven seas. And then eventually when it says go away, the thing stops, and you've built this up over a process of 4. If we just gave them the whole thing and all of the logic required to make a fun pirate chatbot at the beginning, then there would be too difficult a decomposition problem. So we do it this way so that they're led by the hand. And so also the teachers are led by the hand. If we look at the solutions, we can see that there are teachers' notes that show how we got there. What are the steps? Break it down so that the teachers can talk to the students. And we've changed the design of this course a little bit early on so that there are 2 problems for each new concept rather than just one, so that the teacher can do one on the board and then set the second one for the students to do by themselves. And there's really only a change of text at that point. Okay? So that's challenge 1. There's 3 others to go and explore. Go to the website, aca.edu.au, and have a look, sign up for a workshop, and hang on a second. Champion teachers are a thing. So we have a place where you can go and offer to sign up as a champion teacher. You're at PyCon, so you're our people. We need you to test this stuff out in your classroom, to tell us what's working, what would be better if, to tell us when you want a workshop in your area and maybe that you'd like to host it, to give us feedback, to give us ideas for what you'd like for future challenges, and we'll slot those into what we're already working on. And you might get a t-shirt. They are coming. Okay. And finally, are there any questions? I have to dob in some extras. Nikki, please wave. Bruce, please wave. These are my fellow ACA compadres, computer education specialists, and we're all available for the whole weekend and today to come and have a chat, tell us what's great about Python and why you're using it in the classroom, and just ask us what's going on. We'd love to have a talk to any of you.
Thank
Anything
you.
else?
We have... because this is being recorded for a video, if you have a question, I will bring you the mic. Any questions? All right, I'm going to go back here first. Bruce, you have a question.
So Amanda, what exactly do champion teachers need to do?
They need to go to the website and they have to click the button under Champion Teachers. It's really not difficult to find, and that will generate an email that comes to our team, and we want to stay in contact with you, so when we start a dialogue, then you become a champion teacher. If you just press the button and then like disable your email account and we can never get in contact with you again, that might be a problem. T-shirts are difficult to deliver at that point, but generally stay in conversation with us, be contactable, and for future projects we might give you advance notice and ask for feedback and get you to, teachers are very good with the red pen. They're always telling us when we have a typo, do that. That's awesome.
So I know that Victoria in its wisdom didn't adopt the national curriculum wholesale. They decided to make some changes.
Yeah.
Is that similar in other states, and how are you sort of going to manage? Are the differences subtle, or are they gross? How's that going to be managed by the ACA, I guess?
Yeah. So the national curriculum is all of the points, and that's why the national curriculum is a little bit fuzzy. It's because it was kind of expected that people wouldn't just say chunk. Queensland did. Western Australia has their own flavour, Victoria has their own flavour, New South Wales is getting their own flavour, but the content descriptors of what's required are still the same, the fundamentals are still the same. So we're meeting the content descriptors are then generally and meant to be cross-referenced back into the state-based curriculum, so it all links together, and yeah, the if statements are pretty standard.
Any more questions? Yes.
My question is with regards to the Supergirl slide that you had. Okay, in my experience, I've never had learners where they liked programming and then later on they decide that it's not nice anymore or such. But
sorry, did you say you've never had that experience?
I have not had that experience, yes. But I do have an experience where I start a programming club that's now outside of the classroom. So I have girls that I'm struggling with. Okay.
Mm-hmm.
So what they do is we have programming lessons and they have the interest to come to the lessons because they signed up for it, but they don't stay long enough to actually understand the content. So in the beginning, everything is difficult and they want to quit. So I want to learn from you, like, how do I keep them motivated? Because I know that if they stay, those who stay long enough, they love programming. Because the first thing is interest, and they sign up, they have the interest, but they don't stay long enough to understand and start understanding how fun programming is. So sometimes I find it difficult to keep them, especially the girls.
Yeah.
The one problem that I see with them is that, okay, fine, they won't do the homework because they will come and tell you that it was too difficult for them. And then sometimes they also don't show up for classes. So that's also that causes, it contributes to the whole issue. But I want to learn from you guys how you keep them motivated, because I also have another problem, which is now to keep them patient enough when there are errors and such. You know, they get frustrated and they think it's difficult, they can't deal with it. But I know how fun programming is because I've been there myself. It was difficult and then it got easier and I loved it. So I know they will get there, but just to keep them there long enough is what I'm struggling with. So
yeah. I only teach girls and have in my teaching career. So this is something that I face often, yearly, termly. And I've found in my experience, and that's the thing that we're trying to work with the ACA, is that if you have the end goal in sight, and we do that at the Girls Programming Network as well, and Nikki and I would happily talk to you in more detail at any of the breaks, that if they come in the morning and they don't know anything and it's going to be hard, if you just say, okay, here's some theory, here's an if statement, practice this abstract thing, then there's no buy-in. So if you say, okay, we're going to make a Magic 8-Ball game, And this is how we're going to get there. We have to learn how to take input. We have to learn how to make something appear on the screen. So these are the steps that we're going to take to get to that end goal that you want to solve. And in my code club now, the girls have got to a point where they have just enough to kind of have a future vision of what they'd like to do. And so we did programmable electronics recently, and they've decided that they want to make a Rube Goldberg machine that has some programmable switches that make balls go in different directions. And so they've defined that end goal. And so I can then work backwards and say, well, in order to do that, you need to make this happen. So let's make this happen. And here's the steps of how to do that. And then after they've done that for a little bit, they start to decompose their own problems. It's a long haul. But if they can see the end point coming out there on the horizon, I think it keeps them more engaged when they hit those problems. Does that answer?
Yes, in a way, yes. So you are suggesting that I have like projects already like coded, which they can see, and then I guess we work our way from how you can create that program, or how.
Well, that's how we do it at GPN. Okay. Is we have the tutors develop the code to start with, and then work backwards to work out which bits need to be done where, and then start with Hello World.
Okay, thank you.
Okay.
Okay, any more questions? Yes, another one at the back.
This is quite related, but it's not related, and you're going to go, ooh. So I work with people with disabilities. I go into a lot of the schools within the Lake Macquarie area, close to Newcastle. And so you often find within that geographic area, the NDIS came on board. So that's going national next year. So nationally, there will be the ability for children with disabilities. Sometimes we're talking Supergirl may have a diagnosis of a disability that might be Asperger's or on the autism spectrum.
Yeah.
And so therefore they've got a great aptitude, and what you're doing is wanting to foster that.
Yeah.
And as a teacher, it's really hard because you know there's a gap. And that gap can often next year, when the NDIS roll out nationally, be fulfilled, not in a school environment, but in the ability for tutoring in regards to coding classes. So, for instance, in our area, there's a number of innovative approaches that can help support students to be able to build the skills necessary, or for the person with the higher aptitude to go on further and be supported with extra tuition outside of the school environment that can support them with the curriculum if they're struggling.
Okay,
So,
great.
Thank you. All right, another question? Oh gosh, too many questions.
Thanks. So just a quick question kind of relating to one of the earlier ones. Is there a repository of really engaging activities that are simple to get started with? We often find that the kids, if they need to learn too many bits and pieces, that's where they start to drop out. But like the Mad Libs one, the Magic 8 Ball, the chatbot, which are really, really easy to get up and going, are there places where we can find more of those activities to drive that engagement before we start getting into some of the harder stuff?
Not at the moment, but just let me get to Wunderlist and we'll make sure that comes.
Great question. Yes.
Hi, my partner's currently studying to become a primary teacher. She's in her final year right now. And she was told when she started that they were the first year of doing a new curriculum at the uni. So it's supposed to be as up to date as the uni comes. Not the slightest mention of any of this anywhere through any kind of computer programming or related. Yeah, she's not at Melbourne. But yeah, are the unis being brought along and forcing them to
some unis
cover the
are
curriculum?
better than others. It tends not to be the big eight, to be honest. But there are some unis that are really pushing this. I know that I did a master's at Charles Sturt, and that was trying really hard to get teachers engaged with this, and I know a teacher at Southern Cross Uni who came from Australian Catholic Uni, who both of those universities are pushing it really hard. There are only a couple of universities in New South Wales that even mention technology as a high school discipline. It's like we're very much secondary, and so yeah, we need to engage with unis to get them to do pre-service with the future in mind, or with now in mind.
Yes, I suppose the problem is how do you actually get this across to teachers if not even the new wave have any of it?
That's true. Handily, the ACA resources are all free for teachers.
Yeah,
so they can get on board and learn before the students so that they feel comfortable before they go into a classroom.
Thanks.
Okay.
The questions are multiplying. Okay, we're probably not going to have time for all of these, but we've still got time for a couple more.
Hi, I'll just be really brief. Just got a question around the Grok platform that you were demonstrating before. Are there costs around access for that for students, or is?
Okay, so the government has funded Years 5 and Years 7. So for those courses that we've developed, they are free for all of the country for Years 5 and Years 7. We have to verify that the students are in Year 5 and Year 7 because that's the funding model. But they are accessible to other years at a subscription fee. Yeah, and so is a whole lot of other stuff. I actually, in my classroom, use the Grok Learning platform as a replacement textbook. So we chucked out the textbook. And so now we do our web unit using the HTML course on Grok. We do our programming unit using the Python course and NCSS challenge. We do the robotics unit based on the microbit. It's just insane. So I don't need a flat paper textbook that is out of date by the time it hits my desk. I can use something that's dynamic and that is interactive, and the students can run things and see how they work in the browser.
Great, thank you.
Hello, thanks for your talk. I'm not a teacher, I'm a software developer.
Yeah.
What can I do to help teachers specifically and the education system in general teach computer science, programming, abstraction, etc. well?
Okay, so there are some forums that exist for you, and we love people like you. If you watch the keynote in the talk tomorrow about Code Club, that is a really fantastic way to get involved. If you were female, then the Girls Programming Network would be a great place for you to get involved. Code Club is distributed, so they develop content, but it gets run by volunteers in locations all over Australia, and I'm sure it's growing to the world now. And so volunteers in each of those locations can take this curriculum that exists and deliver it to a bunch of high school or younger students, and having those kinds of skills allow you to be a better teacher for those students. There is also CSIRO has a program where professionals can sign up and then get adopted by a school to help teachers directly. So that's a cool program. There are things out there. If you touch base with us a bit later, we can come up with some more. Yeah, we want your spare cognitive load.
Okay, that is all that we have time for this session because it is morning tea time.
I'm not going anywhere.
But Amanda will be around to answer any more questions that you have. So please thank Amanda one more time.